Okay, I'm Dennis Anderson, chair of the Jersey Shore Group of the Sierra Club. That's Monmouth County. And the way it works is the Sierra Club comes with the programs, the speakers, and Brookdale supplies the room and the students. It's terrific. Okay, now, Sierra Club got started in 1892 by a man named John Muir. He found that there were some millionaires were going to close off Yosemite to the regular people. And he said that should not be done, and he got 4 people to work with him. So 5 people around his kitchen table, they plotted how to save Yosemite from the millionaires. Now, these were just guys earning maybe $5,000 a year, $10,000 a year back then, in 1892. I don't know how he managed it. If you want to succeed, find important people to work with you. He got to know President Teddy Roosevelt. Not only that, he got Teddy to go on backpacking trips in the highlands of Yosemite. And Teddy said, "This shall not come to pass." Not only did he save Yosemite, Teddy Roosevelt and people like him saved Yellowstone. And and the other thing that Sierra Club did, they got the National Park Service started, like Yosemite, Yellowstone, Sandy Hook. That's all the same process. Okay, now Steve has something to tell us. See, I can tell. I can just.
So on the table in front of everybody here are 3 action sheets, 2 green and 1 red. I want to talk about the 2 green ones. There's a crematorium planned or proposed in nearby cemetery in Middletown. Lincroft is part of Middletown. The proposed crematorium is gas-fired and might cremate thousands of bodies per year. It would be near hundreds of houses and near thousands of other nearby houses. And we, right here, are sitting 4 miles from that crematorium. When the wind blows our way, we could be breathing the noxious fumes. So the local community in Middletown is up in arms. And this is a repeat, actually, of 6 years ago. A crematorium was proposed, the same cemetery, and the people of Middletown fought it down and won that battle, and I was one of them as well. And so I live nearby, and so I'm also involved this time. So I have 2 requests. First, please open and sign Tell Middletown Zoning Board Stop Fairview Cemeteries Polluting Crematorium Proposal. And so that's a letter, very easy. You scan the QR code and then fill in your name and you click send, basically, and that's it. And so it only takes a minute. So the crematorium site is in a highly sensitive environmental zone, a crucial habitat for endangered and threatened species. New Jersey requires that construction must be at least 150 feet away from wetlands boundary, but the proposed asphalt driveway is 6 feet away and violates the New Jersey requirement. But this might only delay the crematorium as it's currently proposed. So my second request, and the best chance for long-term success, is New Jersey legislation. It's already been introduced in both the New Jersey Senate and the Assembly, but we need your support to get that passed. So the second green form is what I'd like you to do. Scan it and let the legislators know they have your support to get it passed. And the bill would restrict crematoriums from being built within 1,000 feet of parks, schools, houses, and conservation areas. So pick up your phone, scan, and send a letter. I thank you for your action.
All right, I just wanted to bring your attention. There's a table in the back, Clean Ocean Action. If you want any information about that, they do some really great things for our area, for the ocean. They organize and manage the beach sweeps every fall and spring. So great organization. Go back there for some information.
Say your name.
Yeah. My name's Ryan Jacobs. I'm a biology student here at Brookdale, and I was asked to read a little something to you. This is for the NJ Bill S-1029/A-4137, the Invasive Species Management Act. On the table is a summary of the New Jersey Invasive Species Management Act that is being considered in the state legislature. We are asking for your support on this bill. You can click the URL code on the summary and get to the Sierra Club Take Action website, where you can fill out your name and address with an already created message that will automatically be sent to your state legislature in support of the bill. This bill will prohibit the sale, distribution, import, export, and propagation of certain invasive species without a permit from the Department of Agriculture. The bill currently lists 30 invasive species of plant to be banned, including the tree of heaven, Bradford pear, Japanese barberry, and English ivy. So at this time, if someone in New Jersey is interested in planting a tree of heaven in their yard, they can go to a nursery or order the seeds or plants online and plant it on their property where it could be easily spread to other properties. This bill will prevent somebody from planting this invasive plant. A second major feature of the bill is to establish the New Jersey Invasive Species Council to oversee and manage invasive species issues in the state, and to work with our neighbor states in control of invasive species. This bill is not unique, as 45 other states have already passed laws to restrict invasive species, including our neighbors Delaware, Pennsylvania, and New York. Invasive species are destructive to our environment as they outcompete native and endangered species, degrade native habitats, reduce water availability, and damage our crops, resulting in reduced crop yield and increased use of herbicides. In fact, the economic cost to our agricultural industry in New Jersey is estimated to be about $290 million per year. Also, the spread of harmful invasive species, along with the habitat destruction and climate change, is a major reason for the accelerating loss of biodiversity and record high extinction rates. Some of these plants are also disease and insect vectors. For example, the tree of heaven is a favorite food source of the invasive spotted lanternfly. The Invasive Species Management Act is an opportunity to protect our agricultural land, forests, and waterways from these destructive species. So we ask that you please support this long overdue legislation. Thank you.
Got a QR code for that, too?
It should be,
Sir?
if I'm not mistaken, it is this red sheet that was passed out to each table, correct? So you can find it on all of your tables if you're willing to participate. Thank you.
Hello, everybody. Tonight, we're happy to welcome Davis Bush, whose key responsibilities involve work with educators and students in his capacity as the Streamwatch Schools Coordinator for the Watershed Institute here in New Jersey. The Streamwatch Schools program, administered by Davis, helps students to learn about the parameters of clean water that we are protecting by monitoring streams. He leads courses for educators to learn stream surveying techniques, including visual, chemical, and biological. Davis earned his degree in marine science and sustainability from SUNY Stony Brook before coming to the Watershed Institute in 2024 here in Pennington, New Jersey. He was a 2024 Rising Leaders Fellow for Justice Outside. Justice Outside is an organization that bolsters social justice and equality through connecting young people to nature and professional opportunities in the outdoor sector. You may have heard the Chinese proverb, "Give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime." Well, the second half of that proverb can only hold true if the water is clean enough to fish. Thanks to Davis and his colleagues at the Watershed Institute, New Jerseyans have a better chance to be fishing for a lifetime. We look forward to Davis's continued work that will help all of us and can inspire students of New Jersey to pursue careers with nature and environmental science. And as you can see in this sign that Davis has set up and materials for you to take afterwards about their work. Inspiring future leaders is what Davis Bush is all about. A warm welcome for Davis Bush.
Thank you. Thank you. Thank you. Okay. So I'm going to go ahead and get started. My name is Davis Bush. Nice to meet you all. I'm with the Watershed Institute. I'm going to start this off by saying I went a little overboard with the caffeine before I got here, so I'm going to try to I'm going to try to be chill. I'm going to try to be chill and not talk 100 words a second. But if I'm going too fast, let me know. Just call me out, okay? So today, of course, I'm the Streamwatch Schools coordinator for the Watershed Institute, but today I'm going a little bit beyond that, actually a lot beyond that, because we do a lot of other things. And although I don't have as much of a focus on those things, I know a thing or two. So with that said, stream monitoring and our role in mitigating stormwater runoff. So I'm going to start this off with a little spiel about the Watershed Institute. Our mission is clean, healthy, and safe water for all. We want that for ourselves. We want it for all of you. We want it for your friends, your family, your grandma, your dog, your cat, the plants, the animals, the land. We want it for everyone because everyone deserves clean, healthy, and safe water. And we accomplish that mission, or we strive toward that mission in a couple of different ways. We have conservation. They are the people who are taking care of our reserve. We have the advocacy team, and they are the ones who are always pushing for the regulations that we want to see, making sure that we're being the change that we want to see in the world. We also have the science team, and they are the ones who are often collecting data to inform the policy change that we're trying to see. I'll talk a little bit more about that later. And then we have education, and that's me. I'm an educator. And yeah, when we talk about education, there's kind of a natural thing that happens in our brain of like going straight to the little ones, the kids, right? But education, it happens at all age levels, right? So I need to educate all of you. You all need to educate me. We're educating each other. It goes all the way from the very oldest all the way to the very youngest. So that is what we are trying to do with our education department. Our home, I want to start this slide off by recognizing that the land that the Watershed Institute Reserve is built on is also known as Lenapehoking. Lenapehoking is, of course, the traditional and ancestral land of the Lenape people. It takes up all of New Jersey, parts of New York, and parts of Delaware and Pennsylvania as well. And we honor their continued presence on this land, past, present, and future. They did a very good job taking care of this land for so long and still do to this day. And yeah, we like to honor that because they continue to teach us how to take care of it as well. Now, the Watershed Reserve is about 950 acres, so lots of beautiful land. We got streams flowing through it. We got forested areas. We got meadows. We got lots of animals to look at. Our building is a LEED Platinum certified building, which if you don't know, basically means that it was built keeping the environment in mind. Our building was created with the intention to minimize our impact on the environment, and we do that through various forms of innovative green infrastructure. I'll talk a little bit about that later as well. And in terms of location, it is a little bit of a ride from here. We're about an hour west in Pennington, New Jersey, which is about 20 minutes north of Trenton, about 15-20 minutes west of Princeton. But yeah, it's well worth the trip if you're able to make it out there. And a little more about our education programs. We want to offer education programs in order to inspire particularly young people to care about the environment and to learn about environmental issues. We have public programs for kids. We have preschool, homeschool. Of course, we have field trips. We have summer camp. A little bit more about those field trips. We strive to improve science literacy. A lot of our programming is all about data collection and data analysis. So we're making sure that we do that. We also secure funding to provide these same opportunities for schools in overburdened communities who don't have the same resources, who otherwise might not have the chance to learn in an outdoor environment like this. All right, so I'm gonna start this off Well, I've already started a couple times, but I'm going to continue this and get into the meat of this presentation by talking about what is a watershed. I want to ask the audience, actually, how about let's do, if you live in a watershed, put a thumb up. If you do not live in a watershed, put a thumb down. And if you're not sure, let's put it somewhere in the middle. All right, all right, all right. I'm seeing a little bit of everything. A lot of thumbs up. So, we all live in a watershed. All of us, every single one of you. We all live in a watershed. A watershed is any area of land where the surface water flows down to a single point, particularly a single body of water like a river or a lake or the ocean. All of those things are called watersheds. And so every single person in this room lives in a watershed because when that rain or when that water flows over the land, it's got to go somewhere. So that's what watersheds are all about. And watersheds are not bound by any state or political boundaries, because a mountain range doesn't care if it's in New Jersey or New York. If the water lands on the mountains, it's going to flow down the mountains. And so, for example, the Watershed Institute is in the Stony Brook Millstone Watershed. Well, I'll call it the Millstone Watershed. So basically, within the Millstone Watershed, when there's a big precipitation event, when there's a heavy rainfall, some of that water is going to go into the ground, but a lot of it will not. And so that water that does not go into the ground is going to continue flowing over the land. And within that Millstone watershed, it will eventually collect in the Millstone River. I also do a lot of work in the Assunpink Creek watershed. So if there's a big rainstorm there, all of that surface water that does not go into the ground will eventually end up in the Assunpink Creek, which will then go into the Delaware River. You can see some of the labels of different water management areas, but really it's kind of like there's watersheds inside of watersheds. There's watersheds, sub-watersheds, and it really expands. And the reason I say this is because I want to get across the point that we're all connected here. So, even, branching out even further, we have the Atlantic Ocean watershed, we have the Pacific Ocean watershed, the Arctic Ocean watershed. So if something happens over by me, way west of here, it's going to have an impact over here as well, because all of these waterways are connected in one way or another. And with that said, I'll go into how we can protect our watersheds. So how do humans impact our waterways? We do that in lots of different ways, right? I'm sure you're familiar with a lot of these things. I do want to get across that as we're looking at some of these things, like, for example, agriculture or transportation, I'm not saying these things are bad, right? We need some of these things, and that's totally okay. But while we're doing these things, it helps to understand the impact that they are having on the environment, and it helps to strive to do better in the future. So I'm not saying you can never drive a car, but it does have an impact, and it's worth understanding. All right, what is runoff? So that is basically, you could see urban runoff, industrial runoff. That was one of the things on this slide. And that's going to be where I'm going to be putting a lot of focus on today. So runoff essentially is what I was referring to before. So when there's a big rainstorm, again, some of that water is going to go underground, but the stuff that does not go underground effectively becomes runoff. Now, as that runoff is flowing over the land toward whatever body of water, depending on what watershed we're in, so for example, I'll use my own, as it's flowing over the land towards the Millstone River, or another stream that flows into the Millstone River, it is carrying with it various forms of pollution. I'm going to talk about that a little bit on the next slide, but just to go over some of the terms here, infiltration refers to that initial sinking of the water into the land. Percolation refers to how capillary activity and gravity make that water sink some more, go deeper into the ground. Interflow refers to how that water can make its way underground toward a stream or another body of water. And then we have base flow, just to go over that really quickly. That refers to water that is deeper underground, and it is one of the factors that keep the stream flow going in between precipitation events. Excuse me. And then we have infiltration and runoff. So that's where I'm going to be focusing on more. Stormwater runoff. Precipitation that does not infiltrate into the ground. Instead, it flows over the surface, carrying pollutants with it as it travels to a body of water. So in this image, for example, you can kind of see the difference on the right-hand side. We have surface runoff over a more natural region. And on the left-hand side, we have runoff that's occurring in a more urban environment. So in an urban environment, there is less space where that water can sink into the ground. We call that permeable surface. So urban environments have a lot less permeable surfaces typically. And so what you end up with is a bit more runoff, or actually a lot more runoff, which can, of course, contribute to more pollution. Stormwater runoff impacts, lots of stuff, right? Increased losses from flooding. Of course, as time goes on, we all recognize that climate change is increasing our severe storm frequency, and we are having more extreme weather events. And so that runoff is bringing all of these pollutants into our waterways. And like I said before, all of our waterways are connected. And so when it finds its way into one waterway, it's kind of just spreading everywhere. And so a lot of what we do is trying to slow down that water so that it's not carrying as much pollution. That can also lead to an increased presence of bacteria and other harmful organisms. So this is a public health concern, right? So if someone is giving you a hard time, you're trying to have a conversation with them, public health, right? Human health, that is something that's relatively uncontroversial. This is a public health issue. And environmental injustice concerns as well, right? So what I want to talk about when it comes to this is when that runoff initially brings the pollution to a waterway, it doesn't just stay there, right? Instead, that water is going to continue flowing downstream. And as it flows downstream, it's going to collect and kind of pool more. And so, unfortunately, what ends up happening a lot of the time is the people who are creating the pollution, the people who are the biggest contributors, often are not the ones who have to actually deal with the negative impacts that go along with that. And that's where environmental injustice comes in, because it does disproportionately affect people of color and low-income communities. I'll talk a little bit more about that later as well. Natural versus urban stormwater drainage. I talked about this a little bit a couple slides ago, but this kind of gives you a clearer picture of it. So percentages, right? It shows you the percentage. Again, this is just an example, so it's going to vary depending on where you are. But you can see in the natural environment, 40% goes up in the air as evaporation. A lot more of that water is going to infiltrate into the ground. And then what you end up with is only about 10% runoff. So it's not going to be carrying that much pollution toward our waterways. Whereas in an urban environment, a lot of that water is not able to sink into the ground the way that it is in a natural environment. And so you can see the difference, 25% infiltration versus only 5%. Oh, okay, well, we got 10% shallow infiltration and 5% deep infiltration. But you can still see that there's a very big discrepancy there. And we got 55% runoff. And so again, if you're living in a more urban environment, a lot of the time these pollutants will affect your waterways more than if you were living in a more natural or rural region. So with all that said, the reason that we collect our water quality data and the reason why we monitor our streams at the Watershed Institute is so that we have a better picture of the impacts that this runoff is having, both in our watershed and in other watersheds as well. And we do that through a couple of different kinds of data. Before I proceed with this, I do want to say that this is going to be a non-comprehensive list. I've stuck mostly to the ones that I'm most familiar with, but there's a lot to get into here regardless. We have visual habitat data. Let's get to that one first. And this basically helps us get a better picture of the area we're working with, the habitats. We are making lots of observations, like, for example, is there lots of woody debris in these environments? Is there lots of, what's the tree canopy like? Is the stream, does it have a rocky bottom? Does it have a sandy bottom? All of these things help set the picture, and they inform a lot of the data that we're going to be collecting afterwards. So it's really important to get a visual, and also personally as an educator, if you're going out here with students, you got to ease them into it, right? Because they're all excited. So you say, okay, we're going to set the scene first, let it soak in, and then we can move on to some of our other data collection. Biological data. This is, of course, the part that is usually the most engaging for students, looking at all of the critters in the stream. We have a couple different ways that we can collect this biological data. We can, of course, go to the stream, grab our nets, grab our boots, and get that sample that way. But I also want to call out the leaf packs. You can see a couple of them. Ooh, yeah, I got a pointer. You can see a couple of them pictured up here. And how that works essentially is you take a mesh bag, you fill it with leaves, and you tie it to a stream. You secure it in a stream by tying it to either a rock or a log or something that's not going to move, basically. And you just leave it there. You leave it there for about 3 to 4 weeks, and during that time, some stream critters, benthic macroinvertebrates, benthic meaning they live at the bottom of the stream, macro meaning they're big enough to be seen with the naked eye, you don't need a microscope or a magnifying glass, and invertebrate, of course, means no backbone. So over the course of those 3 to 4 weeks, those benthic macroinvertebrates are going to colonize that leaf pack because it provides shelter and it also provides food for many of them. So then at that point, after a bit of time has passed, you can take that leaf pack out, you retrieve it, and then you bring it to whatever location you want to identify the macros and get your sample. You open it up and you see what's in there. This is really great specifically for situations where you cannot safely get to a stream or it's just not accessible. So with students, this is really great because sometimes it's even just a logistical nightmare to get students out to the stream. And so leaf packs are a really great solution to that because it makes this type of data collection more accessible to everybody. So when it comes to those macroinvertebrates, I have a few examples up here. I also brought with me, if you want to take a look later today, these are not live macros. They are preserved, but if you want to get a closer look, you absolutely can. But the deal with these macroinvertebrates basically is they are not all at the same level of pollution tolerance. So some of them, like the scud and the leech, do not care. I mean, like, they care a little bit, but like, for the most part, they're like, I don't care if the water's clean, I don't care if the water's dirty, I'm gonna be here anyway, because I just can. Whereas the ones over here in the pollution sensitive category, they can only be in that habitat if the water quality is at a certain level. And if the water quality is not good enough, they either die or they have to move somewhere else. And so what they can do for us is they are a great indicator of stream health. Excuse me. They're a great indicator of stream health, particularly these sensitive macroinvertebrates, because if they're present, it gives us a pretty good idea that, hey, this stream or whatever this body of water is probably pretty healthy, probably pretty clean. Or if they are absent, it could be an indication that the stream is not particularly healthy, which is also okay because there are things that we can do about that. So yeah, that is how we use these macroinvertebrates as an indicator for stream health. We also...
Tell everybody what a leech does for a living.
A leech is a parasite, and so it's going to be sucking the blood of its prey. I have not... what was that? Oh, sorry. I have not run into this issue with any of my students. I always tell them, they don't want you. They want other things. You're so much bigger than them. But yeah, that's what a leech does. They don't care. They don't care. They're going to be pretty much everywhere. I found that, oh my goodness, they're everywhere. But don't worry about them. They're fine. Okay, chemical data. So this is my personal favorite. I love chemical data in particular because I just love seeing the way that students interact with these parameters. Because chemical data, chemistry in general can be very daunting, right? And so I like to show people that, yes, you can do this. Yes, it is important. And yeah, it's fun too. So the parameters that we collect, well, I'll talk about them right now. But these chemical, like there's probes that you can use, like pictured in this bottom left photo. And that can make this process a lot easier or harder depending on your level of technology ability. And then we have test kits, different test kits. Those can vary depending on grade level, but it is a lovely experience for anybody who wants to do this. So I'm going to go through these parameters one by one, talk about why they're important and what humans are doing to impact these parameters, starting with temperature. Of course, the obvious answer, climate change. Climate change is going to affect the temperature, right? And so that can have a wide range of impacts in both freshwater and in saltwater environments. For example, it can impact the reproduction patterns, just behavioral patterns in general, and distribution. You know, I said before that this is not exclusive to freshwater environments. You know, today we are seeing things like lobsters sort of migrating more north now because of climate change. Sea turtles as well. Like their range in terms of these species are kind of, it's changing. And we don't really have a full picture in terms of predicting how, like, what's going to happen and the full range of impacts. Right?
Hey, I'm sorry.
Yes.
On the temperature, it's most important that warmer temperature holds less oxygen.
Yes. Yes, absolutely. No, yeah, thank you for bringing that up. But yeah, warmer temperatures, they hold less oxygen as well. So yeah, as temperatures move up, they will have less oxygen dissolved in that water to respire, and fewer things are going to be able to live there. Salinity. So salinity, this one is near and dear to, not near and dear to my heart, but it's close to home for me because I work primarily with freshwater environments. So this is also brought to our waterways through runoff. That's kind of like the common theme here is runoff is going to impact all of these parameters in one way or the other. So road salt is particularly a problem in the winter because of because we're salting our roads. It keeps us safe. I'm not saying we should stop, but while we're doing it, it's helpful to try to think of alternatives and to understand the impact that it's having. And it poses a problem for marine ecosystems, saltwater environments as well, because it can mess with osmoregulation, and generally it just creates a habitat that species are not used to. I also wanted to bring up a Flint, Michigan connection, because because most people are familiar with this, right? Just to talk about it a little bit, there was a situation in Flint, Michigan. Lead pipes got corroded, and a lot of people drank contaminated water, and it had very bad health effects on a lot of people. And the chlorides from road salts was one of the major factors that contributed to that. Now, that was not the only thing that contributed to that. Of course, now we know, we've always known that this situation was avoidable, but unfortunately, this is another example that exemplifies that these issues are not necessarily treated with the same level of proactivity when it concerns communities of color. Of course, Flint, Michigan is a primarily black community, and this is another environmental justice issue that I wanted to bring up because, it's important. These things are so intertwined. You cannot talk about one without talking about the other. And unfortunately, a lot of people don't want us talking about this right now. And I'll leave it at that. Turbidity. So this is a measure of water clarity. It's easy to confuse this one with color, but they are different. So you can see these two images. We would both say that those display low turbidity because you can see to the bottom of the stream. However, they are different colors, right? So in the picture on the right-hand side, there might be something else going on. There's probably some sort of iron input that's causing that sort of color, but the turbidity is still low. Okay, murky water is high turbidity, and higher turbidity is typically considered to be a bad thing. Now, this is very species specific. You can kind of see some of the impacts that it has. I also want to point out that the amount of time that these organisms are exposed to certain levels of turbidity, that has an impact as well. So if you are in a low turbidity environment, but that turbidity level is staying constant for a long period of time, it can still have a big impact on the organisms, the creatures that are living there. This is a very general graph. I mentioned before, it's very species dependent, right? There are certainly lots of species that are happy with turbidity, right? Because I can hide better. I don't have to worry about predation as much. But generally speaking, we want turbidity levels to be low. If turbidity levels are too high, a lot of creatures cannot find their food. It can get in their eyes and their gills. They don't like it. So generally, we want to keep turbidity on the lower side. Applying some StreamWatch data. StreamWatch, I'll talk about this a little bit later too, but it is a volunteer program that we have at the Watershed Institute. Volunteers monitor many different bodies of water within our target area, and that helps it helps us inform policy change and just get a better picture of the habitats that we work with. So the reason I bring this up is because it's an example of why this data can be useful. This happened in about 2019. One of our StreamWatch volunteers, Patty Maslanka, noticed that the Cruiser Brook was a lot more turbid than usual. So when we caught wind of that, the Watershed Institute wanted to figure out what was going on. Our policy team, our advocacy team got involved, and what we found was that there was a quarry operating upstream of this location that was operating on expired permits. So when we found out about that, we worked with the quarry, we worked with the DEP, and we updated those permits, and you could see after that, the turbidity started to go down again. Now, of course, after a couple of years, we started to see it went up again. We got to stay on top of these things, right? But this is just one example of how that StreamWatch data, how this stream monitoring can be used to enforce regulations. Moving on to, yeah.
To get those permits, like for the quarry one, how much would that cost?
Unfortunately, I don't know. Fortunately, I can't tell you. Yeah, that would be a question for the policy team at the Watershed Institute. So sorry, but I don't know the answer to that. Yes.
Does your organization, your institution, follow up on penalizing organizations that launch environmental regulations like this? Because it seems to happen all the time.
Yeah, unfortunately, it's a situation where we have to focus on what we can. There are bandwidth issues, there's funding issues, but yes, absolutely, we would follow up. Yes.
Oh, you would follow up?
Yeah.
Oh, good.
Yes.
Call 1-800-888-4DEP.
Yeah, we work with the DEP, we work with our partnerships, and try to stay on top of things like this. Thank you for the questions. Moving on to nitrates and phosphates. These are some of the chemical pollutants that we look for when we are monitoring our streams. There are others, but these are the primary ones that we focus on. They can enter our streams, enter our waterways, once again through runoff. So that storm water is flowing over the land. It's carrying things like fertilizers, pet waste towards our streams, and then it is accumulating in our waterways. Now, nitrates and phosphates, of course, they are natural. They're supposed to be in the environment, but when humans are doing things to add more of these things to the environment, that's when we start to have an issue. So again, fertilizers, that's a big one, and industrial discharge, drainage of wetlands that help prevent the accumulation of these substances all contribute to things like harmful algae blooms. Can I see everyone raise your hand if you know of a harmful algae bloom somewhere in your region? That has happened maybe in the past couple of years. Okay, a few hands. They're happening, and they're becoming more frequent because of things like this. So essentially how this happens is the increase of concentration of fertilizers and organic compounds like nitrates and phosphates. They cause a bloom of algae. So the algae is all using those nutrients, and the process continues from there. So that algae will be consumed by lots of organisms, lots of animals that are living in that area. And as they're consuming that, they're also respiring. So they're using up the oxygen that's dissolved in the water. And then eventually what we're left with is oxygen depleted zones. So that oxygen concentration is going to continue to go down and down. And that's how we end up with oxygen dead zones. That process is called eutrophication. And yeah, we try to prevent that. Dissolved oxygen, that is something that we all need. You know, they just don't use it the same way that we do. They have their gills to absorb the oxygen, and we, of course, use our lungs. It dissolves naturally in the water through the atmosphere, and aquatic plants can also increase those oxygen levels. And it is brought down by things like rising temperatures and the harmful algae blooms. All right, talking about pH a little bit, this is another thing that we have to test for, the burning of fossil fuels. So the vehicles that we use and the factories that we build, they put these fumes into the air, and that has an effect on our rainwater. Now, rainwater is usually a little bit acidic. However, these processes cause it to be more acidic, and then when it precipitates, of course, that will have an impact on the pH of our streams and the ocean as well. You also might be familiar with acidification. That is something that we primarily talk about when it comes to the ocean, but it can happen in freshwater ecosystems as well. If you're unfamiliar, ocean acidification happens when there is a higher concentration of CO2 in the atmosphere. It gets dissolved into the water, and then it reacts with that water, and it leaves a hydrogen ion, which of course is going to decrease the pH. That was a simplified version, but that's the process of how it works. I don't love this graphic because I think that the stream pH that you see up there, I think that that's a little bit off. Usually surface water sources are a little bit more basic than that. But I really want to point out the overlap between the pH of the acid rain and the pH at which fish will start to die. Yeah, it's a pretty big overlap. So we got to keep on top of that pH measurements. Macroinvertebrate collections, I brought a data sheet that we use at the Watershed Institute with me if you want to get a feel for how that data collection would work. Again, a slightly simplified version of what we might do as adults, but when I am doing this with students, it really gets the point across of the sensitive versus the tolerant macroinvertebrates. When we're filling this out, we're not so concerned about the number so much as the presence or the absence. So again, if there's a stonefly or a mayfly present, they are sensitive macroinvertebrates, and that can be an indication that the stream is pretty healthy, pretty safe. And so we use that to get a water quality rating towards the end. And we use all of this data to sort of tell a story. So if I'm at a stream site and I see this data, I might, make some observations on it and think, okay, this is pretty good stuff for the most part. Most of it is falling within that water quality standard. But then wait a minute. What's happening to these nitrates? What's happening with these phosphates? What's going on? And so that is when we start to question where this increased concentration is coming from. Is it something that's going on in our community, or is it something that's happening upstream of here that we should start to take notice of because now it's coming down and affecting everyone else's habitats? So yeah, all of these things are connected, and this data helps us think about that a little bit more closely. So what can we do? I want to talk a little bit about stream buffers. So that is an area of land leading up to a stream or another body of water that is protected. We want lots of native plants growing in that region, because as that runoff flows toward the body of water, those plants do a lot more than just giving us oxygen. They also absorb excess nutrients, they prevent erosion, the eroding away of our stream banks, and they also just generally slow the movement of water so that there is less harmful runoff entering our waterways. And this is more of a regulatory thing, so I do want to just call out, make your voices heard. Particularly, I gotta say, at the local level, make your voices heard. New Jersey is a leader in environmentalism in a lot of different ways, and stream buffers are one of them. So let's keep that going. Let's please keep that going, because things are very uncertain, and we want to make sure that we are continuing to move forward. And while we're talking about making our voices heard, I do want to talk a little bit about Streamwatch Schools. That is, of course, the program that I coordinate, but there is a little bit of a connection here. So particularly when it comes to forming community and communicating our data to other people in our lives. So we engage students through inquiry-based learning, and we help them collect and monitor local streams, basically. I won't go too much more into it than that. But once we collect that data, we also upload it to a central online platform called Monitor My Watershed in collaboration with Stroud Water Research Center. And each one of these points represents a different school. So the reason we do this is to really get that point across of connectivity, right? Because all of these waterways are connected, and we want to invoke questions like, well, if our water is looking a little bit different than someone else's water, why might that be? And is there something that we can be doing? So knowing really helps inspire activism and inspire change. We have the Streamwatch Schools Forum. Again, I won't talk about this very much, but it is an opportunity for these students to share their findings. We invite town council representatives. We also invite mayors. It gives everyone an opportunity to kind of become an advocate, and it shows that, oh, people really want to listen to us. People want to listen to you. You can become a river-friendly resident. Now, the river-friendly program is something that the Watershed Institute is a part of, and it basically is a way to let us know, it is a commitment. It's a commitment to educate yourself, educate other people on issues concerning our streams, and to do better yourself, and think about ways that you can be reducing runoff or just protecting our streams generally. So I have there's a QR code here. I also have it up here. I have lots of QR codes for you, as if you haven't seen enough already. But this is the River Friendly program. We do it for residents, individual residents. We also do it for businesses. If you have a business that might want to be a part of this, we do it for schools. We do it for golf courses. I don't know if anyone knows of any golf course representatives, but that is an option. Okay. And then I want to talk about some of that green infrastructure that help us become river friendly and help us slow down that runoff and take some of those pollutants out of our environment. A green roof is basically plants on the roof. Of course, there's a pretty significant cost associated with this, so it's not something that most people can just do on a whim. But if you have a business, for example, that might be something to consider. This increases that infiltration, right? So when there's a big storm, roofs are typically impervious surfaces. And so those impervious surfaces allow for a lot more runoff. But the green roof allows for infiltration instead. So that water is going to sink and the plants are going to drink it up. So that's what we like to see. We have rain barrels as well. This one is all about disconnecting that stormwater from that path that it's moving along. This is very important because on roofs especially, there's a lot of contaminants that can accumulate there. Bird poop can carry lots of diseases. And yeah, it's a place where those contaminants can really collect over time. And so when you have a rain barrel, it can stop that flow of water as it's moving towards a nearby stream. Most people use that rain barrel water to water their plants. And yeah, we love doing stuff like this too. If you're interested in having a rain barrel, you can scan the QR code and I can point you in the right direction for that. We have rain gardens. So rain gardens are a collection, like a garden. A rain garden is a garden, if you couldn't figure that out. But it is native plants, and they are placed strategically off of a roof to catch that stormwater and make sure that it's infiltrating instead of running off and going into the waterways with all of that pollution. So these rain gardens, they are typically in a lower area of land so that that water can really collect there and pool there. They typically involve plants that really like to drink up a lot of water. And yeah, it can really help disconnect your property from the path of that water that's going to pollute our streams. Permeable pavement. This is another thing that's kind of gaining a lot of traction. But again, it increases the infiltration. So as that water comes down, instead of flowing over the land, it can sink. So for example, asphalt. That is a huge impermeable surface that is kind of everywhere. So if we start to replace those impervious surfaces with pervious surfaces, that water can sink down instead of carrying that pollution. You can become a salt watcher. That's another thing. I have a little more information. I have QR codes up here for this as well. This is another thing that anybody in New Jersey can be a part of. And it is really important right now because we've had a lot of snowstorms lately. And so we've had a lot of road salts. This helps us keep track of that and monitor that. So if you're interested in joining our Salt Watch program, it is a volunteer program, and you get some test strips. You bring it to a body of water that is close to you, and it helps us monitor the salt levels so that we can understand if there is going to be impacts of those chlorides. Okay. Yeah, it talks a little bit more about this here. You can register online. If you happen to not be a New Jersey resident, you can still get involved. I can point you in the right direction for that as well. And if you are interested in this, sign up soon, because I think for this season, I think for the 2024 to 2025 winter season, it's going to be closing on March 1st, but you can still get involved, and we might have a few more storms coming up this winter. So really helps out a lot. So I'm going to talk about a couple of other programs that are a bit more region specific. This is the focus area of the Watershed Institute, so I would imagine it's out of your range for a lot of people in this room, but if you happen to maybe work in this region, it stretches from like Trenton all the way out west to about Millstone Township is probably the furthest it goes. But you know, if you have friends or family in that area, if you have a business, you work there, you can still absolutely, or if you're just willing to travel, you can get involved in these programs too. So April 12th, April 26th, April 27th, we have our annual stream cleanups. So yeah, this happens at lots of different municipalities in our region, so you can absolutely get involved with that. I have a QR code for that too. Or if this is too far for you or you just don't want to, beach sweeps are amazing as well, so you can I believe that there's a few people who can point you in the direction of those beach sweeps. And yeah, generally, thank you for listening. Let me know if you have any questions, any comments, any concerns about what I've talked about. And yeah, keep in touch. The Watershed Institute is open every single day, and we work really hard to try to protect our environment. Thanks. No? Question?
Just describe, when you take a group of children out, what is it that they do? What do they actually do in the stream?
Yeah, when we take a group of students out, we start with a visual assessment so that, getting a feel for the habitat. Is there a habitat that we can work with? Are macroinvertebrates going to be present? Then we usually break them up into groups, and then one group will do the chemical tests. We have test kits for that. Again, depending on grade level, we might use tablets, and older kids can do things like titrations. And then we have the biological tests. So if we're able to go out to a stream, that's when we take out our nets. We have our D-nets. We can flip over rocks to try to find the macroinvertebrates. If we find something else that's cool, that's not a macroinvertebrate, like a turtle or a salamander or some fish, that's also very cool. Or if we are not able to go out to the stream in person, that's when we would put out a leaf pack for them. And then we would open that leaf pack and collect the data that way. And from there, we would analyze the data, talk about what it means and why it's important.
And so does the same student group go out a few times, or is like you move from school to school?
Well, I mean, it depends. With Streamwatch schools, the idea is that they would continue this. Like after they learn how to do it, they will make it a part of their curriculum. But if it's a field trip, they come when they come,
And how long is an outing?
With whatever time I have to work with. Everyone, it's a little bit different. Sometimes it's an hour. Ideally, it would be like 3 hours, because then we can really, really dig into it. But, I work with what I got.
Thank you.
Of course. Yes.
When you mentioned salinity, you said that maybe there's alternatives.
Yes. So when I talk about alternatives, that maybe wasn't the best word. But if you are interested in SaltWatch, they have a lot of stuff on there. Even if you can't do the testing yourself, they have lots of resources for you to become an advocate, for you to become an educator. But it also talks about the best practice when it comes to salting, like in terms of a lot of the time we use more than we need. And so we'll talk about the best way to make sure you're using only what you need. But in terms of actual alternatives, the one that I am familiar with is you can use sand instead. I am not in a position to tell you how much more or how much less effective that is, but we absolutely can use sand as well to break down the ice. Yes.
Actually, that was sort of a segue because there's other alternatives where you don't have to put salt all over every sidewalk on a property. I went to the library yesterday, Alpin, I guess, and I saw like you don't want to put salt everywhere. You want to funnel people to like a few doors when there's a lot of snow or ice. Like don't just have free for all every sidewalk that's open. You make less availability so that only those key areas are salted to,
Very good point.
From Minnesota had a lot of good tips.
Oh, I'm sure they do. I'm sure they do. They have to deal with this kind of thing a lot. But yeah, thank you for bringing that up. Yes.
So I have a few questions about your organization. How large is the Watershed Institute? Like, how many people strong?
Oh, okay. I would say, I don't remember for sure, but something like 40 staff. About 20, 25 of them are full-time, and then we have some interns that come in the summer and a large team of volunteers as well.
Are you more just on the analyzing the data collection side of things, or do you also work like the Sierra group does here with local political campaigns?
Well, In my time at the watershed, I'm not familiar with any political campaigns that we've been personally very involved in, unless as it relates to like policy decisions that we want to see, you know?
Are there any like large achievements or accolades that the institution has made in the local area that you can think of? Something that they can point to, like a large difference they've made?
Great question. Large difference that we made. I feel like I'm going blank. Yeah, but I'm trying to think beyond that. We have a lot of schools. Yeah, touching on the impact of that, we cast a very wide net when it comes to the number of people that we serve. We have the Watershed Conference that just happened last week, on Friday, which is basically like a gathering of environmental leaders, whether they be representatives or educators or scientists, where we share ideas and things like that. So we're 8 years strong when it comes to the Watershed Conference, and it's pretty well attended, like a couple hundred people. Yeah, you're welcome. Any other questions? Yes, over here.
I'm curious about the native plants carriers. Is there a law or people are just doing that voluntarily?
It is a law now. Let me see if I can go back. But yeah, it depends on what stream exactly we're talking about. So I mentioned here, if I can find it, I didn't think it was that far back, but I was wrong. There it is. So stream buffers. So for Category 1 waterways, it requires a 300-foot stream buffer. Category 1 just refers to waterways that have been identified as particularly environmentally sensitive, like they would have very widespread impacts if they were not adequately protected. So it's 300 for Category 1. I know sometimes it can be something like 100 or 50, depending on what the stream is, depending on the waterway. Wetlands, as was mentioned before, is typically 150, but yeah, it varies.
Okay, thank you very much.
Thank you.
Nice job.
Thank you, Davis.